If any word starting with a special character, double quote, single quote, underscore, 9 or something, any other special character, underscore, any hashtag, question mark, any character, those all should go into reducer 27. It means the file, different file. So how we will do this? How we will do this? So what needs to be done? So can anyone tell me logic for this? Only logic. I don't want what how you write in the mapper and reducer. How you will find the first character, and how will you find the whether it is a first character or last character, and how you will decide to which whether to go to which reducer. Yesterday I have explained this and I have shown the code as well. Now please try to tell me how we can achieve this. How we can achieve this. Just give a guess. Anisha, Ganesh, through ASCII. Okay. Okay, how could you please tell me the logic, Harika? Sachin, Sai. Guys, am I audible to everyone? I think everyone is in mute or... Okay, fine, understood. Let me explain. So first, what is your K1? Long writable. Long writable, which is offset. What is your V1? Complete line, which is a text. Which is a text, right? Now, if I want the words, what I need to do? I need to break this word. I need to break this line into words. What I will do? String s value, string value equal to value dot, I mean v1 dot toString, v1 dot toString. After doing that, what will happen? It will convert into string. Why should I convert into string? Why should I convert into string? Can anyone tell me?
Because that Hadoop only understands text, and we are working with strings, so to break it.
Hadoop won't understand text. Hadoop understand text only.
Text only, but we are working to, break the string, split our string tokenizer, so we don't
No.
have those methods in
Why?
text.
Exactly. That is the point. So the value is what data type? Value is what data
The
type? It is a text data type.
text.
The text does not have your split substring,
The string tokenizer.
this kind of, not string tokenizer. String tokenizer is a completely different class. Okay, so that kind of
Okay, yes.
APIs are not there in this, right? So if I want to break a complete line into words, either you have to go with a split or you have to go with a string tokenizer class. The string tokenizer class will take only, your string tokenizer class takes only strings, not other format of other data types. Your string tokenizer class will take only strings. Your string tokenizer class will take
Strings, yes.
only string. It's nothing else. So you have to pass a string here. So this is text type. If I pass text type here, no, I cannot understand this. It will say I cannot understand. That's why we need to convert into string, right? Once you convert into string, then you can go ahead and break it using string tokenizer, or you can directly say that string value dot split by space, and you store that into array of strings. Now you get all the words. The words has been divided. You got the words, right? What will be your map output? Your map output very simple, as similar as a word count only, right? as similar as your word count only. So what is your map output? You'll ctx dot write, what you will do, word comma 1. What is this word? Your word is nothing but a word you have given from this. So the words are like either Hadoop, HDFS, whatever the string you have taken, Java. These are the words, right? These are the words. Yes or no? From these words,
Yes.
I need to bring the first character because I want to split based on the word start with. Let's say the word is started with a H, it has to go to sixth reducer or sixth or seventh reducer. How? Sixth or seventh file. All the words which start with the H has to go in different file. All which start with the J has to go in different file. All which start with the A, B, or they will go different files. What we need to do for that? You need to do your word dot. This is the output of mapper, right? This is output of mapper. I'm talking about a
Yes.
partitioner now. Okay, let me show the code. I think
Yes.
code will make you much clear. Okay, that's your mapper output. That's your mapper output. See here what I have done. You have converted into toString, you have converted into broken into tokens. Either you can do a tokenize, that's what I said. Either you can do a tokenize, either you can do a split, right? You have done the tokenizing. So after tokenizing, you set it into word. You guys know why we set it into the word, and you emitted the word comma 1. So while it is emitting, it's also call your partitioner method, get partition method. It is not after short and shuffle, it is not after your map output. Before going to map output only, it will call get partition method. It will call get partition method. If you write your own partition method, I mean your own partition logic, it will call that. If you didn't write it, it will call default partitioner. As I said before, it will call default partitioner. What is the default partitioner? What is the default partitioner? Can someone tell me what is the default partitioner? Kishore?
Hash partition either.
Okay. Harika? Are you guys there with me? Rakesh? Sai? Vaishnavi? I'm only hearing from Srinivas, no one else. Okay. So if you didn't specify any partition in your logic, it will call default partition, which is called hash code partition, and it will apply that logic. But here we are writing, right? We are overriding it. We are specifying that I need my own logic, which is customized, and I'm specifying get partition class, and I'm overriding my get partition class here. I'm specifying this is my logic. You calculate the partitions based on this logic. You don't use the hash code partition. You use my own partition. That's what we are specifying here. Then
Okay.
as soon as the key value pair has been calculated, what it will do, what it will do, it will it will identify, and it will call this get partition. It will identify what is the partition ID. What is the partition ID? This is called partition ID. Whatever you're emitting, right? We'll call this a partition ID. So the partition value, you can say partition ID or partition value. Okay, and then what we are doing, we got the K2, we got the V2, and we got the number of reducers. What is the number of reducers? So how many output files you want? How many output files you want? That is number of reduce. Or if you want to better performance for your job and you are not going to worry about the how many files output is coming, we will specify those many number of reducers. Okay, in our case 27, because 1 to 26
Yes.
has to handle the alphabets and 27 one has to handle the special characters,
Special characters.
right? So what we are doing here, then we are taking the word. So word is what type? It's a text type. I need to convert into string. I convert it into string because I'm going to do some string operations. So why I need to convert? Your text does not have these operations. Your text does not have these operations. So your text to do this lowercase or trim or uppercase or substring or split, this kind of operations if you want to do on your text, you have to convert into a string. So that's why I have converted into string here. Then I'm after that I'm converting into lowercase. Why I'm converting into lowercase? As I said before, irrespective of it is starting with a capital letter or small letter, I have to keep it in a single file. That was my idea. So what I have done here, so I have converted into string, then I have converting into lowercase. So if I convert the lowercase, even though it's coming as a capital letter, it will convert into lowercase, right? I'm finding the correct of zero position. Zero position means the first position. The first position. The Hadoop, I want to get the first character. How will I get the first character? Caret of. There is a method called caret. So you'll get the first position. So first letter. Then it will convert into, irrespective of whether small or capital, it will convert into lowercase and it will do the ASCII. It will find the ASCII here. It is finding the ASCII. Okay. And ASCII modulo by number of reducers. Modulo by number of reducers. If I is 0 to 25, if I is 0 to 25, you are returning I. It means either you're returning 0, 1, 2, 3, 4, 5, the numbers. And if it is not that, if it's something else, you are returning 26, which is a hard-coded one. Why? Because the special characters. If I'm not getting, if I'm not getting anything between the 0 to 25, it means that there's a special character. That means that that's a special character. So I'll be emitting that into different file. That will be I'll be emitting into different file. So what kind of scenarios we will go with the partition? Very simple, guys. When you want an output, a specific type, like all male has to be in one output file, all female has to be in one file, all departments has to be in one, all department. Suppose like there are some employees who are belong to department called Hadoop, all has to go in that file. So when you want to segregate, when you want output in different files, we will go with the partition. Not only partition, there is something called multiple output format. We will talk about that later. There is something called multiple output format. If anyone wants to make a note of it. So when you want the output into multiple files or multiple directories or multiple uh, you want to separate the outputs in differently based on the key or based on the type of the data, you can keep it in a multi-output format or you can go with a partition. Okay, so I have written my partition logic here. I have written my partition logic, and your mapper and reducer is similar, guys. Mapper and reducer, nothing goes change. Your mapper and reducer is not going to change anything. Okay, then in the red driver class there is a little change. In the driver class you have something called little change. The change is your job dot set partitioner class. Job dot set partitioner class. What we are doing? Job dot set partitioner class. If you didn't do this partitioner class, by default it will take hash code, but I'm specifying, I'm overriding my own partitioner class. Suppose let's assume that if you didn't specify the word count class, what will happen? Your word count mapper, what will happen?
So it
Kishore,
is gonna execute that default.
it will go and execute the default, which is called identity mapper. It's going to execute identity mapper. If I didn't specify the reducer here, what will happen? It will go and execute the identity reducer. The same way, if I didn't specify this partitioner here, it is going to execute default partitioner. That's called hash partitioner. Okay, let me, we already written this code separately. Let me take that. Let me, where is our sgraph? Not sgraph. This is our 630, right? So already have a word driver here, already have a mapper here, already have a reducer here. So I'm going to put this as well here, partitioner also. So now, because I don't want to make you confused by showing you so many files, that's why I'm separated here. So driver class, in the driver class you need to set word count dot set partitioner class. What is your partition class? Word count partitioner.
Partition.
Word count partitioner dot class. Dot class. And you forget about all the input format and all those things. We are not going to talk about them. We will talk about them later. Okay. And go to your mapper class. It is long writable. So my partitioner class, I need to change it. If you observe here my partition class, I'm taking int writable. So it'll throw error. So I'm going to take long writable. Long writable. Okay. And here also long writable. Okay. Good. So we can remove the unnecessary things. Okay. So your reducer also taking long writable only, no doubt in it. And say now let's go ahead and execute this. As shown yesterday how to execute in the local mode, let me execute one more time for you guys in the local mode, and then I'll execute in the cluster mode. So you go as run configuration, and already we have this. I want to take arguments because I don't want to these are the arguments. Here WC multiple multiple reduces multiple reduces apply. So can anyone tell me if I run this, will it create multiple outputs? If I run this, will it create multiple outputs? It will not create. Why? I didn't set the number of reducers. I didn't set the number of reducers here. I didn't set the number of reducers. WC dot set number of reduced tasks 27. Until I set this, that's not going to execute multiple reducers. I thought someone will tell me this point. No one is tell. Okay, let's go ahead and execute now. Right click, run as Java application. Get here. You can see number of splits here. Okay. The data is successfully created. And where the output will be? What is the path you have given there? What is the path you have given there? I didn't observe. I just copy pasted. I didn't observe properly. What is the path you have given? Local MR input multi-reducer. Local MR input multi-reducer. Go here. MR input multiple reducers. How many reducer output files are created? 0 to 26. It means 27 output files has been created. 27 output files has been created. Look at guys here. This is 41 bytes, but this is 0 bytes. It means there is no word start with Y. There is no word with start with Y. This is also 0 bytes. This is also 0 bytes. Sir, it is creating so many unnecessary 0 bytes. No, I don't want to create. Is there any mechanism to do it? Yes, there is a mechanism to do it. We can suppress the empty part files by using lazy output format. There is something called lazy output file format. By using that, we can suppress 0 bytes part files. So there is no point to create this one, right? So we can suppress them, okay, by using lazy. That we will talk about anyway in file input formats. So we have a separate session for that. So now this is the I have executed in local. Let's go ahead and execute in the cluster mode. What are the files I need? I need a driver class, I need my mapper class, I need my partitioner, I need my reducer. Then I need to export export jar and your jar file. So here already the jar file name is telling pigudf, but I don't want to give as a pigudf. Partitioner, wc partitioner or multi-reducer, multi-reducer, finish. Okay, just a warning, finish. Go to your terminal, check whether the services are running or not. All the services are running, clear them. What is the command to execute in MR mode? What is the command to execute in MR mode? Anil, Harika, Kishore, Anisha, anyone?
Hadoop jar
Hadoop
name, job.
Hadoop jar,
driver class name.
path of the jar, right?
Yes.
Home,
Yes.
Hadoop 1, jars, desktop, jars, WC multi-reducer, and the driver class name. And your driver class name in fully qualified driver class name. Fully qualified driver class name com.test dot and your driver class name. You should give fully qualified driver class name com.test dot space input. What is the input you
Input.
want to give? I want to give input. I want to give input of this file. I want to give input of this file. But if I give this input file, the block says 128 MB. So only one mapper will launch. So I don't want to do that. I want to show you multiple mappers are launching. So if that is the case, this is also 64 MB thing. I want to show you 32 MB. Yep. I have test2. There is something called test2. So I'll give this as input. I'll give this as input. And I'll give output also same, but I'll change the location. Training multi reduce. Okay, press enter. It will take quite a long time because it is a very little bigger file. Not is very big file, it's a little bigger file. And also if you see here, how many splits? 9 splits. Parallel process. To make you understand, this is the one of the example. 9 mappers are going to launch. I'll show that. It's taking quite a long time because, as I said, it's a little bigger file. It seems that it's taking so much of time. No, it is hanged actually. That's the reason it's not showing. Okay, let's give some time. Oh, sorry guys, it is hanged. That's why it's not showing the process. Yeah. It is processing 9 mappers, right? That's why it is taking a little time. It's really going slow because only one machine. If it is a parallel process, it could have been multiple machines has been there, but it's only one machine, right? I mean, what you're trying to say is correct. Okay. So here, if you see how many mappers, why the question is why reducer started before completing mapper? That is the question, right? So how many mappers are launching? 9 mappers. In the 9 mappers, there may be 1 or 2 mappers are who completed already, right? So that mapper output is collecting at this page, at this phase. Okay, so at the 67% of the total 9 mappers, it means few mappers are already completed. Now the reducer is launched, it has started collecting the data from which are all completed mappers. Already the mappers are completed, no? That data is collecting. Wherever you reducer launch to collect the data from other machines, it's collecting now. And as soon as your map is complete 100%, it means all 100 map or 9 mappers are completed. All your 9 mappers are completed. Now your reducer start processing actually. That's why. So this is the frequently asking question in interview. Even so many people ask me in the nothing. So I used to see in the console without completing mapper, I'll be seeing the reducer. But as we know, after completing mapper only reducer has to launch. Why? That's what. If you're launching only one mapper, yes, if you clearly you can see that once the mapper is complete, then only reducer launch. If you're running only one mapper, after 100% only reducer will start with 1%. But when you're launching multiple mappers, that case, some of the mappers may complete it, right? As soon as any one of the mapper complete some tasks, some produce output, your reduce will launch to collecting that output. That is why we'll be keep seeing this. Clear, Anil?
Yeah, I got it. But it will wait until all the mappers complete, right? Even though it starts
Yeah.
reading and collects, it
Yes.
just collects the data. That's it.
Yes.
It
Map
won't be
logic
like
will not wait.
when exactly. So that's what I'm trying to say. Like when
Yeah, I
it's
understood. Yeah, I understood that point. That's why I said okay. So your
yeah,
map reduce logic will not execute until you 100% complete.
exactly. So all the mappers have to be completed before the reducer logic starts, but it starts collecting the prerequisites from the mappers which are completed.
Exactly. Exactly. Because once all 100% mappers is completed, then only it will take all the output, then it will go through sort and shuffle phase, no?
Yeah.
Why is it taking so much of time? 740 is already. Because I have taken a little bigger file. That's the reason. What if one of the mapper fails? One of the mapper fails, you might know the speculative execution. It will try to launch the same job in other machine. Even still it is failing, the job will fail. And the question from the Srinivas is, if any one of the mapper fails, what will happen? So we might have heard about the speculative execution. We have discussed about it. If one of the map task is failed, what your reducer will do, sorry, what your job tracker will do, your master, he will launch the same job in other mission. Same job because we have 3 replications, right? If there also it is failing, it means something wrong with our logic. Something wrong with the logic. If it is something wrong with the wrong with the logic, it will fail anyway. It will fail. The job will fail, right? If the wrong with the machine, it will launch the job in other machine. Where other machine is good, it will start pick up and it will start run the things. Understood, Srinivas?
Yes, Ravi. Yes. Thanks.
Are we missing any data locality? Are we missing data locality anywhere in the Hadoop? We're strongly saying that Hadoop is a data locality. Is there any case we are missing the data locality? Vaishnavi?
Can you please elaborate more on that? Like,
Okay, so we know what is the data locality, right? We are telling that wherever the data is there, you go and process. That is the data locality, correct?
yes.
So in your HDFS or in Mapreduce or Hive or wherever while processing the data, are we missing a data locality? Are we 100% data locality? Is Hadoop is 100% data locality, or is there some place we are missing data locality? Okay, let me put my question in this way. So what we are trying to say?
Sir, I'm not able to understand your question.
Sorry, ma?
No, I'm not able to understand your question, sir.
Yeah. The question is, we know what is a data locality, right? Wherever the data is there, you process there only. Don't copy the data. That is our concept of data locality. Don't copy the data from one hard disk to another hard disk to process it. So in the Mapreduce, while processing the data using Mapreduce, are we achieving data locality, or is there some loophole somewhere we are missing the data locality? Are we missing a data locality in a Mapreduce, or it is 100% data locality? That's my question.
I think, is it 100%?
Anil?
I didn't get your question exactly. Like,
Okay.
can you please repeat it again?
Okay. The reason behind it,
Because I was thinking, like, are you trying to question you regarding the distributed cache where we take we
no,
place the data,
no,
like, for the
no,
broadcasting? Are you
no, no,
looking
no,
for
no,
that, or?
no. So what is the data locality? My data is there in this machine. These are my machines, block 1, block 2, block 3. So what we are telling, you go and process here. My logic will go and process here, correct?
Right, right.
This is called data locality, correct?
Mm-hmm. Mm-hmm.
So by using MapReduce, are we missing data locality here or not? Data
No, we
locality
shouldn't be
means
missing.
No.
the block 1 is here, the block 2 is here, the block 3 is here. I'm processing the same machines, right? But is there anywhere we are missing the data locality here? Understand, Anil, what I'm trying to say?
Ideally, we shouldn't be missing any data where or there.
Okay, so actually we are missing the data locality here. How? The first mapper will be launched here in this machine. The second mapper will launch in this machine. Third mapper will launch in this machine. Correct? The output of
Mm-hmm.
this mapper will be where? In this machine only. The output
Yeah,
of
it
this
will be
mapper will be
locally there.
in this machine only. Output of this in this machine only. Now the reduce will launch in other machine. Correct? Any of the machine. Reduce will launch here. I need to copy the data from here to here.
Yes.
So you are missing data locality or not?
So you mean to say, like, mapper and reducer will not be happening on the same node? That's what are you trying to say, or?
See,
Because reducer is working on reducer is performed on a different node.
exactly. This reducer can be map node 3, or reducer can
Yeah,
be
that
node
can
1.
be. Yeah, that can be done in any other nodes.
Correct. Now the data output is there which nodes? Which hard disk? This machine hard disk, right? The output of this
Yeah,
machine hard
mapper
disk, right?
output is present. Yeah, mapper output is present in the first three nodes where where mappers are produced, and reducer output is present on the where reducer is produced.
Anyway, the reducer output will finally have HDFS. We'll forget about that. Okay, the
Yeah.
HDFS is nothing but all your data nodes. Okay, so now your reducer is not launching in a different machine, no? Your reducer
Yes.
is launching a different machine. Now it has to collect all the output from other machines.
Okay, so you mean to say it's collecting the data from the different node, it's not processing on the node where data is sitting over there.
Exactly, right?
Okay. Yeah, got it.
Understood, Srinivas?
Yeah,
Yes, right. Yes, got it.
So at the reduce level, we are missing the data locality. So that is the reason we're moving to Spark.
Okay.
Not only that is the reason, this is one of the reason. See here,
that's one of the reasons. Yeah.
the data is moving from this hard disk to another hard disk. We're reading the data again from hard disk to RAM. Again, we're reading the data from hard disk to RAM. So where it is showing some performance issue. Okay, so at the reduce level, we are missing a data locality. We are moving the data from one machine to another machine there. Why we are not considering that is a very big flaw? Because the mapper output will be very less. The mapper output will be very less.
Yes.
And also that's a
Yes.
parallel copy.
Yeah.
That is the reason we are not considering that. But when it comes to the performance, even milliseconds also matters, right? That's why the Hadoop lagging. Okay. So you guys can see here. These are all called counters. How many map tasks are being launched? How many map
It's 9.
tasks are launched?
9.
But one is killed, no? It's supposed to be 10, right? In this case, in that it's supposed to be 10. Why it's
Okay. 9.
reduced tasks are 2. Total reduced tasks are 29. 2 has been killed. Total reduced tasks are 9. 2 has been killed. So 27. That's correct. So what is our how many blocks will come? Total 9 splits. 9 splits means it has to be launched 9 mappers. But here
Yeah.
it is telling 9 has been launched, but 1 has been killed. But it's supposed to be 10. I don't know,
Yeah.
something when maybe relaunched in the same machine. I mean same core, same slot. Maybe that's why it is not counting it. So ideally I have seen it. If 10 mappers will be launched, 1 will be killed. So you can see here, no? Reduces 29 has been launched, 2 has been killed. How many we specified? 27.
Yeah.
We
It
specified
matches.
27. It's matched. Come on, yaar. Why is this much slow today? See? We specified 27, but it's launched 29. 2 has been killed in it. Okay, these are the, you can look at the how many mappers has been launched and how much data has been processed and read. You can easily understand here. So let's go back and see the
Yeah.
output. So that's the output I want to show here. So go here, training. Again, it's hanged. So I will restart. I need to restart my machine things. Come on, there. So let's go down, multi-reducer, and if you see here, you have so many part files, 26 files, 0 to 26. If you go and see the last reducer will contain only special character, the space. All are special characters. You may say that, oh, how come Ravi here these are letters, right? These are characters, right? This is special. This is a space. Space is the special character. They're all. These are all special characters. Started with a special character. And if you go and see 25th reducer, only Z, who start with Z, who started with a
Yeah.
Z. If you go and see 24, who started with a Y. If you go and see reducer 0, who started with A. A. I don't know why this is came. I really surprised, but it's actually to start with A. These are all started with A. Okay, maybe the first character, whatever the ASCII we are taking, right? That ASCII is falls under this plus symbol is might be fall under that. The fall under first case. I mean the reminder came 1 for that. Even this special
Okay.
character also the reminder came 1. That might be the reason. Okay. So this is how we will do the partitioning. So this is called partitioning in this. Actually, I have given this as an assignment, so guys need to do. So that's why I have explained here. Tomorrow we will be discussing combiners. Tomorrow we will be discussing combiner. What is a combiner? Why we need a combiner? After combiner, we will be discussing how Mapreduce works. Then we will be seeing some input file formats, output file formats. Then we'll be moving to Hive, then Scoop, Pig, HBase, and Woozy Flume. So that is a plan no, going for the going classes. Okay. Any doubt, guys?
Yeah.
Okay. Yeah. Thank you, guys. Thanks for your time. Have a great day.
Yeah. Thanks a lot, Roy.
Yeah.
You have
Anil.
a great day.
Yeah. Thank you.